Good afternoon, my name is Emilio Garcia Ladona. I'm going to present the work on the Atlas of currents and their variability in the Mediterranean and Canary Iberian Biscay waters. This is one of the outcomes of two projects. One is the Cosmo, which is a Spanish-funded project, and the other is Medosmosis, which is an Interreg Mediterranean project. So why a climatological atlas of currents? Well, first of all, because current fields are essential ocean variables necessary to understand the ocean dynamics. Heat and mass transfer is determined by the currents field, but also they provide some insight on the marine ecosystem structure, for example, connectivity patterns of populations or how invasive species disperse along a basin. Also, they have a strong impact on socioeconomic activities. Maritime emergencies, for example, pollution events and search and rescue operations, require high-resolution velocity fields. They are very important for designing route optimization and also for efficiency navigation. Why a climatology? Because we want to detect and unveil recurrent and characteristic patterns. Here on the left we have a clear example of it, and we have two satellite images 2 years apart of the same region in the same area in the Gulf of Mexico. The upper one is just the image of oil spill produced by the Deepwater Horizon, and the second one is the chlorophyll sea from satellite. As you can see, they share the same patterns, which in fact are dependent on the currents field that is produced on this region. Also, climatology may serve for rapid assessment of drifting objects and reanalysis of past events, for example in forensic investigations. They are very useful for medium and long-term assessment, typically for times greater than 3 days, which are typically the forecasting system horizon skill. So the climatology we have built covers the area represented in this map. We have kept separately two different areas. One is for the Mediterranean side and the other for the Canary and Iberian Biscay waters. For the Atlantic basin, we have compiled the globe current product, which is basically a geostrophy from altimetry plus an EMAN component fixed with the help of the observation from the SBP program. It provides daily maps at 1/4 of spatial resolution with two levels, one on the surface and the other on the subsurface of 15 meters. For the Mediterranean, we have compiled two products. One is geostrophy from altimetry at 1/8 of degree, and the other is the METSI numerical reanalysis with data simulation at 1/24 degree. For the climatology, we have chosen the median as the representative of the system because it's robust in front of outliers, and we have also decimated daily values into monthly means in order to have enough degrees of freedom for a robust statistics. The time variability is represented by the variance ellipses and the currents roses. All this statistics information has been compiled in a website where you can browse the maps for every month, and also you will have an animation of the currents representative of this month, and if you click any point in the map, you can retrieve all the time variability represented by both schemes. Let's go to see some results from this climatology. First, we focus on the Canary Iberian Biscay waters, and we have represented here the fields corresponding to two characteristic seasons, the winter season and the summer season. In the winter season, the flow is dominated in the north with the western lights, and the flow is mostly zonal. As you can see, we can observe the North Atlantic drift, which goes directly to the English Channel, and then the Western Iberian winter front that as it encounters the Iberian Peninsula, it splits into branches, one going to the north along the Iberian coast and then entering in the Biscay Bay and then flowing along the coast. The southern branch is flowing south just to join the Azores current that turns to the southeast, forming what is called the Canary current. In winter, the flow is mostly meridional, mostly dominated by the trade winds in the south, and then we can observe the signature of what is known as the the upwelling region along the Iberian coast. If we look in detail of this part, we can see in the summer season how the upwelling circulation evolves, and in April it starts to see some signature of the upwelling in this area, mostly concentrated in between 41 and 43 degrees north. Then it starts to be enhanced, and in August arrives to the maximum almost, with important currents flowing to the south and intense currents, and then it starts to decrease the intensity during September, while in October mostly disappears and starts to form the pattern characteristic of the winter season, with the western Iberian winter from arriving to the Iberian coast. All the previous patterns are quite consistent with the scheme published in the previous literature. In this case, we want to go a little bit further in the validation of this climatological phase by comparing with the trajectories of drifters. Here we have two situations, one for the summer and one for the winter. The thick lines in yellow and black represent the characteristic main flow. The dots, the yellow dots, correspond to the first day of the given month. So in this case, for example, we have June, the first day of June, the first day of July, and the first day of August. And in this case, we start in November and we have December. In this case, for the winter season, we have two separated experiments. One corresponds to the data set in orange. These lines in orange correspond to the drifter released during the Prestige incident, and then the red lines correspond to a set of drifters released 4 years later, more or less on the same period. As you can see, the correlation between the climatological currents and the trajectories and paths of drifters are quite good. Now we go into the Mediterranean basin. The circulation in the Mediterranean basin is quite complex. Making an exhaustive analysis of the time and space variability that emerge from these climatological fields is out of the scope of this talk, and it will take a longer talk. So we have just concentrated a little bit on an aspect that has received less attention in the past, which is the difference between the surface and the subsurface circulations. As you can see in the monthly circulation schemes, the difference between the patterns in the surface circulation, for example, for the eastern basin, is quite different from the patterns in the subsurface, which resembles the schemes that has been published in the past. Also note that, for example, the Algerian current in both cases appears to be rectified and deflected toward the central part of the Algerian basin. As you can imagine, this is strongly related with the wind patterns, and if you represent the monthly pattern for the summer, you will see that these strong winds that goes from Greece toward the south are forcing this north-south flow. Also remark that, for example, in the Algerian current, what happens is that the winds turns along the African coast and is in the opposite direction to the Algerian current. So maybe this is the cause to provide this deflection toward the central part of the Algerian basin. Therefore, if we make a zoom over the eastern basin and we represent the surface climatological currents for July overimposed with the trajectories followed by drifter released in this area for this period of time, we can see that they match very close. Note, for example, the set of drifters released in the Otranto state, how part of them follow the north-south flow and how part of them follow the current that is flowing around the Italian coast. Also, look at the a set of drifters released in the Strait of Sicily, how part of them match very close the narrow current that is entered in the eastern basin. So, although this is not a quantitative comparison, the close resemblance between both fields gives us confidence that these climatological fields are not a mathematical artifact and may serve as a first assessment of what is really happening in the field. So finally, let's go to summarize our results. We have presented a high-resolution climatological atlas of currents that has been produced from latest observational reanalysis product from Copernicus services. The climatology here is defined as the median of approximately 30 years long time series. For the Atlantic area, the globe current product is quite consistent with previous published schemes, but the atlas provides a high-resolution representation and captures the seasonal variability. For the Mediterranean area, the METSI provides a complex circulation with surface and subsurface patterns differing remarkably, probably linked to the mean wind patterns. The qualitative validation with independent data, mainly using drifters, is encouraging on the potential use for operational oceanography, but a more quantitative validation is needed to evaluate the usefulness from an operational perspective. So, thank you very much for your attention, and just to remember to visit our website where you can browse and look at many other details concerning the results here presented. Thank you very much.